We stand at a crossroads in the history of technology. For years, the power of artificial intelligence has been locked behind the gates of a few massive corporations. But a new wave is coming, a movement to decentralize intelligence itself. Imagine a world where AI is as distributed as the internet, where privacy is built into the code, and where no single entity can pull the plug. Today, we're diving into the architecture of decentralized AI. In the modern digital landscape, artificial intelligence has become a concentrated force, controlled by a handful of global giants. We live in an era where massive data centers act as the central nervous system for our most critical algorithms. But this centralization creates a dangerous bottleneck, where a single point of failure or a policy shift can disrupt the entire ecosystem for millions of developers worldwide. As developers, we have grown accustomed to the black box model, sending our data into a proprietary cloud and hoping for the best. However, this model faces growing scrutiny. Privacy concerns, high costs, and the threat of censorship are pushing us toward a new frontier. What if we could break the monolith? What if intelligence wasn't hosted in one place, but everywhere simultaneously? Welcome to AI for Developers by Chaitanya. Today, we are exploring the paradigm shift known as decentralized AI. It is not just a buzzword. It is a fundamental restructuring of how we build, train, and deploy intelligent systems. By leveraging distributed networks, we can create AI that is more robust, infinitely scalable, and inherently resistant to the limitations of centralized control. At its core, decentralized AI is the convergence of distributed computing and machine learning. Instead of a single server farm processing a model, the workload is spread across a vast network of independent participants. These participants provide compute power, storage, and data, working in harmony through protocols that ensure transparency and security without a middleman managing the process. In a centralized system, you are a tenant in someone else's house. In a decentralized system, the community owns the foundation. Centralized AI is efficient but fragile. Decentralized AI is resilient and permissionless. For developers, this means moving from a subscription-based dependency to an open-source infrastructure where your application's logic is truly independent of any single corporate entity's whim. Data is the fuel of AI, but currently, users have little control over how their fuel is used. Decentralized AI flips the script by allowing for local data processing. Through cryptographic methods, developers can build systems where data never leaves the user's device, yet the collective model still learns and improves. This is the first step toward true digital sovereignty for the end user. Privacy is no longer an afterthought. It is a requirement. In a decentralized framework, we use techniques like secure multi-party computation to process information without revealing the underlying data. This allows developers to build AI tools for sensitive industries like healthcare or finance, where data sharing was previously impossible due to strict regulatory and ethical constraints. Every participant in a decentralized AI network is a node. These nodes can be anything from a high-end GPU cluster to a consumer-grade laptop. By contributing resources, these nodes earn rewards and maintain the network's health. For a developer, this creates a massive, global pool of latent compute power that can be tapped into at a fraction of the cost of traditional cloud providers. The backbone of this movement is peer-to-peer networking. By removing the central coordinator, we allow nodes to communicate directly. This peer-to-peer architecture ensures that as long as there are participants in the network, the AI remains functional. It is a self-healing system that scales organically as more developers and users join the ecosystem, creating a truly global infrastructure. How do we ensure people share their hardware? The answer lies in economic incentives. Decentralized AI networks use blockchain-based tokens to reward those who provide the necessary computational power for training and inference. This creates a competitive marketplace where price discovery is transparent, often leading to significantly lower costs for developers trying to scale their AI startups. One of the greatest challenges in decentralized AI is trust. How do you know a remote node actually performed the computation correctly? We solve this using verifiable computation. Developers use mathematical proofs to verify that the AI model was executed as intended, ensuring that the results returned by the network are accurate and haven't been tampered with by malicious actors. Zero-knowledge proofs, or ZKPs, are the secret weapon of decentralized systems. They allow a node to prove it has a certain piece of information or has performed a specific task without revealing any details about the process itself. For AI developers, ZKPs mean we can verify model integrity and data privacy at scale, creating a trustless environment for complex algorithms. In the absence of a CEO or a manager, smart contracts take over. These self-executing lines of code handle the distribution of tasks, the payment of rewards, and the enforcement of network rules. For a developer, the smart contract is the ultimate transparent API, ensuring that the infrastructure behaves exactly as programmed every single time without human intervention. Version control is vital for development, but in decentralized AI, we take it a step further. By recording model weights and updates on a blockchain, we create an immutable audit trail. This allows developers to track the evolution of an AI, ensuring that everyone in the network is using the exact same version of the model and preventing unauthorized modifications to the system. Large language models have massive file sizes. Storing these on a single server is a risk. Decentralized AI utilizes protocols like IPFS or Filecoin to fragment and distribute model weights across thousands of locations. This ensures that the model is always available, speeds up downloads through local peer discovery, and makes it impossible for any single entity to delete or block access. Federated learning is a cornerstone of decentralized AI. Instead of bringing data to the model, we bring the model to the data. The global model is sent to individual devices, where it learns from local information. Only the summarized updates, not the private data, are sent back to the network to improve the master model. It's a collective intelligence built on individual privacy. Think about the millions of smartphones sitting idle every night. In a decentralized AI world, that idle capacity becomes a massive training ground. Developers can tap into this distributed hardware to fine-tune models on real-world edge data. This not only lowers costs, but also ensures that the AI is trained on diverse, representative data from actual users across the globe. Nowhere is decentralized AI more transformative than in healthcare. Hospitals can collaborate to train diagnostic AI without ever sharing patient records by keeping sensitive data on local servers and only sharing model updates. We can create world-class medical AI that respects patient confidentiality and complies with global privacy laws, potentially saving lives through faster, more accurate diagnoses. In finance, proprietary data is a competitive advantage. Decentralized AI allows financial institutions to contribute to shared risk assessment models without revealing their secret sauce or client positions. This collaborative but private approach builds more stable financial markets and helps developers create better fraud detection tools that learn from the entire industry's experience without compromising security. As we move toward a world of billions of IoT devices, the centralized cloud can't keep up. Decentralized AI moves the intelligence to the edge directly onto the cameras, sensors, and drones. This allows for real-time decision-making without waiting for a round trip to a distant server, making autonomous systems faster, safer, and more reliable in the field. For developers building interactive applications, latency is the enemy. By using decentralized edge nodes, inference happens closer to the user. Whether it's an AI-driven gaming experience or a real-time language translator, the reduction in lag provided by a decentralized network can be the difference between a seamless experience and a frustrating one for the end user. When AI is centralized, the provider decides what you can and cannot build. They can change the API, increase prices, or ban certain types of content overnight. Decentralized AI is the ultimate insurance policy for developers. It provides a neutral, permissionless platform where your code runs according to the protocol, ensuring your business isn't built on shifting sands. Who decides how an AI should behave? In a decentralized system, this is managed by DAOs, decentralized autonomous organizations. Token holders and developers vote on model updates, ethical guidelines, and resource allocation. This democratic approach ensures that the AI evolves in a way that reflects the values of its community rather than the interests of a single corporation. Imagine thousands of specialized AI agents, each owned by different developers, negotiating and collaborating on a decentralized network. One agent might handle natural language, another image generation, and a third data analysis. They use a common protocol to trade services, creating a complex, emergent intelligence that is far greater than the sum of its parts. Critics often point to the energy use of distributed systems. However, decentralized AI can actually be more efficient by utilizing stranded energy and idle hardware. By optimizing where and when training occurs and reducing the need for massive, cooling-heavy centralized hubs, we can build a more sustainable future for AI development that aligns with global green energy goals. Security is paramount. Decentralized networks must defend against Sybil attacks, where one actor creates many fake identities to influence the system. Developers use proof-of-stake or proof-of-work mechanisms to ensure that every participant has skin in the game. This economic security layer makes it prohibitively expensive to attack the network, protecting the integrity of our AI models. The economy of decentralized AI is driven by supply and demand. As more developers build on the network, the demand for compute increases, incentivizing more providers to join. This creates a virtuous cycle of growth and liquidity. Understanding these, tokenomics, is essential for modern developers, as it allows them to design sustainable, self-funding AI applications. For decentralized AI to win, we need standards. Just as HTTP and TCP/IP built the internet, we need common protocols for how AI models talk to each other across different networks. Developers are currently working on these open standards, ensuring that whether you are using a decentralized LLM or a specialized vision model, the integration is seamless and interoperable. Centralized servers eventually hit a physical limit. Decentralized networks do not. The more users and providers join, the stronger and faster the network becomes. This horizontal scalability allows for the creation of models that are too large or too complex for any single company to host, opening the door to the next generation of massive-scale artificial intelligence. In a decentralized world, there is no off switch. If a data center in Virginia goes down, the rest of the world's nodes pick up the slack instantly. For developers building mission-critical applications, this level of uptime and resilience is the ultimate goal. Your AI stays online, no matter what happens to the global infrastructure or political climate. High-performance AI shouldn't just be for the elite. Decentralization lowers the barrier to entry. A developer in a remote corner of the world can access the same level of compute power as a Silicon Valley startup. By democratizing access to these tools, we are unlocking a wave of global innovation that will define the next decade of software development. Building for decentralized AI requires a shift in mindset. We must move from thinking about my server to the network. It requires learning new tools, from cryptographic libraries to distributed consensus algorithms. But the reward is a level of freedom and power that was previously unimaginable. You are no longer just a coder. You are an architect of a global brain. By 2030, we expect the majority of AI inference to happen on decentralized networks. The black box will be replaced by a transparent, community-owned infrastructure. AI will be integrated into every device we own, working for us locally, while contributing to a global pool of knowledge that is open, fair, and accessible to everyone on the planet. The infrastructure is being built right now. The libraries are being written. The networks are going live. As a developer, the best time to start exploring decentralized AI is today. Don't just wait for the future to happen. Be the one who writes the code that makes it possible. Join the movement, and let's build a more robust, scalable, and open world together. Thank you for joining me on this deep dive into decentralized AI. The journey from centralized silos to distributed networks is the most important transition in the history of computing. Stay curious, keep building, and remember, in the world of AI, the most powerful system is the one that belongs to all of us. I am Chaitanya, and this is the future of development. The shift toward decentralized AI isn't just a technical upgrade. It's a declaration of independence for developers. As we've seen, building robust and scalable systems requires us to rethink everything from data to governance. The tools are ready, the network is waiting, and the next breakthrough is in your hands. Subscribe for more deep dives into the future of tech. Let's build the decentralized future together.